Hello everyone. We'll learn zinc air batteries into this experiment. There is a broad category of metal air batteries, which are basically electrochemical devices to store the electrical energy. And depending upon the anode material, they are zinc air batteries. We have magnesium air batteries and aluminum air batteries. Okay. So the objective of our experiment is to construct this zinc air battery and try to glow an LED. Okay. So the first step will be to understand the mechanism of this zinc air battery, like what all reactions happen at the anode and cathode. In step 2, we will try to identify the components of this battery, what materials have been used at the anode, cathode and at the separator. In step 3, we will try to construct the cell. We will try to measure the output voltage by a multimeter. And in step 4, we will try to connect this cell into the circuit to glow the LED. First, we'll try to see what reaction happens inside the zinc air battery. Let us consider this as the cell. It is filled with an electrolyte. Typical electrolyte is KOH, aqueous. Okay, so we have OH negative ions solvated into the electrolyte, and we have zinc as the anode. And we'll discuss it in the discharge process. Okay, so zinc will act as an anode, and at the cathode we have it can be any conducting material which is porous. Okay, the porosity is to facilitate the oxygen from air to oxidize or reduce depending upon the process. Okay, in the discharge process the oxygen will reduce. So this is the cathode and this is the anode. Okay, it the those both the electrodes are connected across a load. Okay, so when oxygen is reduced at the cathode, it forms negative ions. The negative ions at the anode will combine with zinc to form zinc hydroxide. Okay. Formation of these ions will give off two electrons at the anode, and these electrons then travel to the cathode. Okay. Now these electrons combine with this O2 from air. During discharge, the reaction at the cathode is the oxygen reduces in the presence of H2 and to give out hydroxide. Okay, let me balance this equation. Okay, so the reduction potential of oxygen in 0 pH is 1.23 volts. Okay, since we are using KOH, which is basic in nature, and let me assume that the pH of the electrolyte is 14. By using Nernst equation, we'll find the equilibrium potential. E naught is okay. R is temperature 298, number of electrons 4, F is 96485, and pH is 14. E naught is 1.23 volt. Okay. After solving this equation, you will get the reduction potential of O2 in the electrolyte that we are using will be somewhere around positive 0.410 volts. At the anode, okay, the zinc metal will first combine with the OH ions to form its first hydroxide, okay, and give off the electron. The first case we can think of is zinc metal being oxidized to form zinc ions and give out two electrons, okay. So in this case the reduction potential is negative 0.76 volts versus standard hydrogen electrode, okay. And the reduction potential of uh, this zinc hydroxide is negative 1.285 volts versus standard hydrogen electrode. In this case, the equation is zinc combines with 4 hydroxide ions to give zinc hydroxide and 2 electrons. Okay. Now to find the cell voltage, we have this equation. Okay. So the cathode is positive 0.401 and minus, if we consider this one, we get, okay. So here it doesn't make sense to say versus the standard hydrogen electrode or anything, but you should always mention this as the cell potential. This word is very important. And in the other case, if we consider this reaction to be taking place, then the E cell will be somewhere around 1.685 volts. Okay. So experimentally, when we find the cell potential, it is always more than this. Okay. It is because the actual reaction that takes place is this one. This reaction takes place, because of which the cell voltage is this one, and due to over potentials and losses you will get the measured E cell, which will be in between 1 volt to 1.5 volt. Okay. At the anode, during the discharge, as I said, the zinc first, this is zinc, will first combine with this ions to form zinc hydroxide, okay, and then give out two electrons in the circuit. This ion then dissolve into the electrolyte. It further goes into a reaction to form ZnO plus OH and water. Okay. So the overall reaction that happens at the anode will be zinc plus OH will give, in the first step it will give Zn 2 minus and 2 electrons, and then this one in the electrolyte it will form ZnO plus 2OH and H2O. Okay. So the overall reaction at anode is Zn plus OH minus O, which will give zinc oxide. Okay. So this is the overall reaction that happens at the anode. To summarize the reaction at the anode, zinc combines with OH minus ions to form zinc oxide. OH ions water and gives out 2 electrons. And at the cathode, the oxygen is reduced in the presence of water, gaining 4 electrons and forming OH minus ions. Now to find out the overall reaction, I will multiply this equation by 2. This becomes 8, 2, this becomes 4, 2, and this becomes 4. Okay. So this and this combined cancels out this. Water. We're left with 2Zn plus O2 will give ZnO. It can also be written as 2. Okay, so now I will teach you how to construct the zinc air battery. But before that, let me tell you one thing which is very important. Since the zinc air battery that we are constructing is a rechargeable cell, but will be only doing the discharge process in this experiment, please do not try to charge it with any DC source available in the lab or the main source. Okay. So for constructing the cell, first I will show you what are the apparatus that are required. This is KOH, which will be the concentration will be told to you during the experiment, and this is the dropper, connecting wires, a breadboard on which the LED has been already connected and the resistor is already connected in the series, 2 clips, a multimeter, a separator, this is a filter paper, 2 different types of cell casing, scissor, a zinc anode, stainless steel mesh. First, this is the lower part of the cell. It is made up of acrylic and it is having a slot engraved into this. Okay, so this is the zinc anode. You will place it exactly into this slot. Make sure you do not take the anode beyond this line. Okay, it should be only exposed at this slot. On top of that, you need to cut a separator, but make sure that the separator is slightly bigger than the anode. this is how it should look. Okay, place the separator on top of it, then place the stainless steel, this is 316 stainless steel mesh, place on it and make sure that the extra part will come at the other end of the cell. Okay, so the zinc should be coming out this side and the stainless steel should come at this side. And now on top of this, this is the upper part of the cell which is having a slot in this. This is to provide the cathode to have the excess of air. Once you sandwich the components, secure the cell with these clips. Once done, then use these crocodile clips to connect the electrodes. When you connect the electrode, make sure that you do not connect two electrodes at a time. For example, if you connect this way, it will short circuit, like the stainless steel and the zinc is in contact with the single electrode. It will create problems. Okay, make sure that one of the arm of this goes inside the separator and you clip the zinc in this way. Make sure no two electrodes are coming in contact with each other. Once the cell is being constructed, connect the terminals to the multimeter. Okay, turn on the multimeter to read the voltage of the cell. You will have to collect the voltage reading as well as the current. The current that you will be seeing shown here is the absolute current. Then you will have to divide the surface area of the electrode to find the current density. Okay, so now the reading, right, and check the voltage. Add few drops on the tissue paper. Once you add, you will see the voltage over here. Okay, since the voltage is negative, which means the terminals have been connected wrong, so just change the terminals to get a positive voltage. Because it's a spontaneous reaction, the voltage value should be positive. So the voltage that we are getting right now is 1.2 volts. Let me check the current. This is how you will measure the current and voltage. Once you have noted the value of voltage of the cell, this is to verify that you have constructed the cell correctly. After that, you need to glow the LED. To glow the LED, you connect the terminals to the LED, and you will notice that the LED doesn't glow. Is because the LED rating is more than that of the voltage that you are providing by one cell. So for that, you will have to connect two cells in series. To connect two cells in series, connect one of the electrode, in this case it's a stainless steel electrode, to one of the terminal of the LED. Okay, so the other terminal, the zinc terminal, should be connected to the stainless steel over here. Okay, and then the zinc terminal, the anode, should be then connected to the other terminal of the resistor. So this is a series connection. Every component in this circuit is in series. Now let us try to glow this LED with the with this series connection. If at all it doesn't glow, which means the LED has been connected incorrectly. So it is not glowing, which means it is not connected. Correct. Now let me check. Yes. This should be the, oh, it is blinking. Maybe not lose connection. The LED is blinking. Maybe the electrolyte is still seeping into the electrode. So some part it is getting connected, getting disconnected. You will try to add more electrolyte so that the LED glows continuously. Yes.